All right, so how'd we do this morning? Well, buckle up. We're going to have a really, really good afternoon as well. So thank you for joining. Thank you to the morning keynote and to our two panels this morning. Let me add my thanks to Mayor Jacobs. She's not at her table right now, but for her continuing support of the modeling, simulation, and training industry, and for co-hosting the fourth annual Florida Simulation Summit. Also, a big thanks to Bev C. I don't see Bev either, but she's over here. Our conference chair for the fourth year in a row, and thank you very much for kind of controlling the morning sessions, keeping us on time, and for once again stepping up for the fourth time as our conference chair. For those of you that I have not met, I am Lieutenant General Retired Tom Baptiste. I'm the President and CEO of the National Center for Simulation, and I am your co-host for this Simulation Summit, and I will be the MC for the afternoon program. The National Center for Simulation is once again delighted to join with Mayor Jacobs in Orange County to co-host this fourth annual Simulation Summit. As an association, NCS and its 255 members remain focused on efforts to promote, protect, and set the conditions to grow the modeling, simulation, and training industry through outreach and advocacy, technology transfer, education, and business development initiatives for our government, industry, and academic partners. NCS serves as an important link between the military and other government at all levels, MS&T industry companies, and academia engaged in research, development, and the application of simulation technology. NCS also serves as a bridge between the traditional defense simulation organizations and other simulation-related communities of interest, and that's why this conference is so important. When it comes to the commercial applications of modeling and simulation in sectors beyond defense, we collectively have a lot to learn. It's now my distinct pleasure to introduce our luncheon keynote speaker. Fram IE is the Vice President, Electronics Industry for Siemens Product Lifecycle Management. With over 30 combined years of experience in the electronics and semiconductor industry at Qualcomm, IBM, and now Siemens, he's uniquely qualified to talk with us about the industrial Internet of Things and what the future holds for his industry and others. Fram, the floor is yours.
Thank you, Tom. I specifically chose this song because I play hockey twice a week, and this is our warm-up song. So I also want to give a special hand to Tom because he did a fabulous job in pronouncing my last name. So it's very difficult to speak, I know, after lunch. And so with all this discussion about digital twin and big data and analytics, and I think just before lunch there was a question over there about the human factor, I thought I would start with a story. And this story is about, let's make this big data and analytics engineer, 40 years old, never been married. And one day he calls up his mother and he says, Mom, he says, I think I finally met the one. And Mom, she's ecstatic, over the moon. He says, look, Mom, I'm going to bring her over for dinner tonight so you can meet her. And I know when you cook a homemade dinner, you always make a ton of food. So she's going to bring with her 4 of her female friends. And you know what, Mom? I'm not going to tell you which one of them I'm marrying, and I want to see if you can figure it out. So they all come over for dinner, and after dinner, Mom goes into the kitchen, and her son runs in after her. Says, all right, Mom, which one? And immediately, without delay, Mom says, the one sitting 2 to your left with the red blouse. And he's sitting there thinking, oh my God, what algorithm is she using? I need to figure this out. He says, Mom, how did you know and know so quickly? She goes, son, it was easy. I hate her. So with that, I'm going to dive in. As Tom mentioned, my area of expertise is in the electronics and semiconductor industry. And although I've only been at Siemens for about 6 months, I've got close to 34 years now between electronics and semiconductors. I like to joke with people, as you probably know by now. I say that the white hair from my right side is from electronics, and the white hair on the left side is from semiconductors. And the fact that I have overall a lot less hair than what I used to, that's due to my kids. By the way, one of my colleagues looked at this and said, "Boy, Fram, that's a really bad digital twin." So throughout these 30 years, I've been fortunate enough to kind of work on a lot of really cool projects. My 12 years at Qualcomm, I led a couple of smart connected products. One program called Windows on Snapdragon, which is taking a ARM-based or Snapdragon processor, putting it into a laptop and computer. Another program called Gobi, which was really the world's and industry's first 4G, 5G technology for IoT and machine-to-machine applications. I've been on both sides of the semiconductor supply chain, running IBM's foundry organization, and then switching over and running the foundry operations team at Qualcomm. And way back when I actually did real work, I did IC and SoC design at IBM in microprocessors and various other chips. Another important thing for me is being able to give back. You know, we talked a lot in the morning session about education, and I've been involved with a lot of different educational efforts, from recruiting engineers to being on Dean's Engineering Council to work on curriculum. And currently I'm an adjunct instructor in engineering and management at one of my alma maters, which is Clarkson University. Go Golden Knights. And also have a master's degree, a couple of them, from the University of Vermont. Go Catamounts. It also explains why, if you know where Burlington, Vermont and Potsdam, New York are, you know that I've earned where I live today, which is San Diego, California. So let's talk a little bit about the electronics industry. In the electronics industry, I like to think of it as sort of 3 different eras. And the first era was what I call the compute era. Kind of started with the mainframe computer and really peaked with the advent of the personal computer. Next was the connected era. And of course, probably the biggest iconic device in the connected era is the smartphone. And today we're in the digital era. And it's pretty tough to probably read this quote, so I'm going to come over here and read it to you. It's from the CEO of Accenture, but it says, "Digital is the main reason just over half the companies on the Fortune 500 have disappeared since the year 2000. So you can see the importance, and it was brought up this morning, I think Bill brought it up, of there's going to be a lot of companies that don't make it through this digital era. And by the way, this is no different than what happened in the connected era and what happened in the compute era. We can all, I'm sure, name companies that, fell by the wayside. So what are some of the trends that we're seeing at Siemens in the electronic industry? So one of the first things that we're seeing is this idea of customized and personalized products, electronic products. It used to be that electronics was just few part numbers, mass production, get it out. Well, that's changing, and the implications of those change drive all the way back into the manufacturing process. So what that now means is products are getting personalized sometimes even halfway or 3/4 through the manufacturing process. Think about when you go order a personal computer and you specify what size hard drive you want and what memory options and what graphics, and you upgrade this, etc. That's, for a manufacturing side, that can be a logistical nightmare. And this is spawning, you'll hear a term in the industry called lot size 1, right? So it's this idea of lots of different SKUs and very small lot sizes. So that's, one big challenge that electronic manufacturers are dealing with. Devices are getting both smaller and smarter. And, the example, obviously, is this smartphone, iconic device. So I worked 12 years at Qualcomm. I'll tell you, the state of the art in a smartphone right now, as they get thinner, is everyone's shooting to get sub 7 millimeter, right? That's kind of the gold standard. But at the same time, with that mechanical problem and challenge that you have, you got to pack more and more stuff in it, right? People want 20 megapixel cameras. They want, gigabit LTE speeds. Just as a side note, because I'm sure a lot of you hear about 5G, the next G that's coming along. So 5G, without going into, a deep technical dissertation, 5G initially is going to be what's called an additive technology. And what that means is it will not replace 4G, which means all the 4G stuff that's in your phone will stay, and they got to put 5G on top of it. So that's another challenge with, again, things getting smaller and packing more stuff in there. The disruptive pull of electronics in mature industries, and I don't know if the mayor is here by any chance, but I was in China last week, and I was talking with a leading appliance manufacturer in China, refrigerators, washers, dryers. And they were just explaining the challenge that they have from people like the mayor and other folks who they want to hook up their refrigerator to the internet, and they want to be able to have touch controls and all these features and functions. And in a lot of these mature industries, like appliances, they don't have that expertise. But on the flip side, they see a tremendous opportunity. And the opportunity is they want people like the mayor to say, oh, I'm not going to wait till my refrigerator doesn't work anymore to replace it. I'm going to go and I need to get the latest and greatest refrigerator because I need that feature. And we're seeing that happen in a lot of these mature industries, including automotive, which I'll talk about here in a second. And finally, the customer experience is king, right? So a lot of discussion this morning about technology and use cases and all this other stuff. But at the end of the day, if we as consumers don't see value both out of the box, right, as well as ongoing, then the device doesn't become very useful or interesting to us. And I don't know about anybody here, but it seems like every Saturday I'm looking for the closest electronic recycling center to take my box full of electronics that I no longer use. So, I talk about the importance of the digital thread and the digital era that we're going in. How's the progress, right? So by one measure, PwC, as part of their Industry 4.0 consultancy practice, they did a pretty big survey. It was over 1,100 manufacturing execs in 26 different countries. And as part of the survey, they looked at a number of different areas of digital transformation, people, business operations, et cetera. And they ranked according to 4 levels: novice, follower, innovator, and digital champion. And what they ranked or determined was only about 10% of the companies really got to the digital champion status. So you can see, despite the fact that it is so vitally important to do this digital transformation, only about 10% of the companies are actually there. And 2/3 of the companies haven't even yet begun the journey. They're novice level or below. So a couple other interesting tidbits, not too surprising to someone like me or people in the industry. Asia Pacific is kind of leading the way right now in terms of digital transformation, almost 20%. A lot of that has to do with the fact that they're able to, through startups and other things, have the opportunity to do greenfield. They don't have to go back and retrofit some of their operations for legacy systems. And you can see the Americas at about 11%. And we'll talk about these 2 industries a little bit more, but the 2 industries that are actually leading the way are automotive, again, another mature industry that's being disruptive, and just the electronics industry in general. So let's take a look at those two industries a little bit more. You hear a lot of talk about autonomous vehicles, right, and getting to level 5 autonomy, right, which is just no steering wheel, you get in the car and it'll take you where you need to go. Well, another interesting statistic that you see on here is in about 15 years, in less than 15 years actually, they're predicting that over half the cost of an automobile is going to be due to the electronics that are in there. So you talk about a major disruption, right? This is it. And similar to the washer, dryer, and refrigerator example, right? This is another industry that's also hoping that you don't wait for your car to just, die, kind of like the car I drove in college, which I kept driving until I just was filling it more with oil than gas. They want people to actually go out and start upgrading their cars because they want to get the next greatest feature that's in there, whether it's GPS, infotainment, all these sorts of things. And then the other big area is smart connected products, right? These two industries together, I mentioned in the first chart about the industry continuing to grow. It's a multi-trillion-dollar industry. These are two subsegments that are really sort of fueling a lot of that growth. So, I explained I've kind of split my time between the electronics industry and the semiconductor industry. And there's always been this tight relationship between the two. Electronics kind of drive the semiconductor industry. In the various eras, for example, in compute, a lot of the advancements that were made in microprocessor and memory was driven by the PC. In the connected era, the advent of the smartphone really took off when 4G and now gigabit speeds got developed in both Wi-Fi and cellular. And as we move forward, and by the way, if you talk to a semiconductor person, I put my other hat on, and the semiconductor person says, well, the reason all that stuff was enabled and they were able to achieve it in the electronic side was because of us, the semiconductor side. So, and so as a result of that, from a Siemens perspective, we look very closely at both the electronic industry as well as the electronic and the semiconductor industry. It's a reason why I guess it's been about a year and a half or so ago, we acquired Mentor Graphics. Mentor is a company, if you're not familiar with, that does a lot of design tools on both IC and electronic board design. We saw the importance and the trend of this and bringing this in as part of the digital thread, which I'll show you here shortly. And we've continued to invest in that area. 3 of the companies that you see down here are all helping to strengthen our portfolio as it relates to either the automotive market or smart connected products. And just to kind of reinforce this point, I actually pulled some data from Mentor and looked at the sales that they make into system houses. And when you pull that data, what you see is a third of the revenue, or the third of the cost of what people are spending their money on, is on IC tools. So system houses are investing not only in system level, but they're investing all the way down to semiconductor and IC level. And, another proof point, I keep coming back to the smartphone. The top 3 smartphone folks, right? Samsung, Huawei, Apple. In that order, by the way. Huawei just overtook Apple. All 3 of them have significant SoC, which is system on chip, IC design, and they continue to actually grow that. By the way, I think you'll see the same trend on the automotive side, because there it's going to be even more important to do some of these things like functional safety and ISO 26262 requirements. It's going to require an even tighter tie between the IC and the system. So the net of all this is, when we look at this at Siemens, we say, hey, business as usual is just not going to cut it here in the electronics and electrical system space. There was a recent quote by the CEO of Toyota, and he was mentioning that to get to level 5 autonomy, right, this is this full autonomous vehicle capability, you have to drive or test drive something like 8 billion miles. And if you work it out in terms of a fleet of cars and trying to do 8 billion miles, it would take you 150 years. So clearly, that's not going to be feasible or possible, right? So these kinds of things are what are driving this idea of the digital twin, or having models in the virtual world that will allow you to simulate the real world, to avoid having to do 8 billion miles of testing. So as a result of that, we look at this and say, okay, we need to change the way we bring ideas to life, right? So this is kind of the design phase, using techniques like generative design. Generative design it kind of mimics the way nature takes its evolutionary process, right? And kind of iterates and makes the next generation a little bit better and a little bit better. Well, we kind of take that same sort of techniques and bring it into the design phase using digital techniques. The next step is how they're realized, right? And it's not just about automation and advanced learning, but there's all sorts of machine learning techniques, robotics, etc., particularly to do the challenge that I was mentioning up front, right? This idea of lot size one and personalized products in a manufacturing environment. And finally, and arguably maybe one of the most important, is how these products evolve over time and their usage, right? This gets into all of the data and analytics piece. And so at Siemens, we call this ideation, realization, and utilization. How it relates specifically into the electronic space, as you can see here, we're focused what we call both horizontally and vertically. So I mentioned ideation, realization, and utilization. That is, you could take any one of these boxes, like IC, for example, and drill down, and we look at the digital twin, if you will, within the IC space. How do we design ICs? How do we manufacture them? How do they get utilized? But then we also do what we call a digital thread throughout the entire supply chain, right? That says from the IC, it goes onto a board, the board goes into a system, and a system goes into a product. And so that digital twin, or that digital thread, is both vertically and horizontally across the supply chain. My last chart kind of breaks down how do we think about this whole digital thread, and what are sort of the key aspects, quite frankly, when we look at it from everything to organic investments at Siemens to M&A and acquisitions. And there's sort of three really key elements to it. So the first for us is the idea of integration. So I mentioned the IC piece, right? A few years ago, we were, imagine electronics through to the end of the system. As we started to look at the importance of the IC piece, we said this has to be brought in and integrated as part of this digital thread. And the other important thing about the integration piece is, quite frankly, for us, we've been at this with Siemens PLM now for 11 years. And what's really sort of cool about that is it's not just a marketing tagline when we talk about integration. We do these exercises called the day in the life. And we're looking at actual customer workflows. We're sitting down with them and saying, what are you trying to connect to what, and pulling all of this together. So the integration becomes very real and practical versus just trying to make it a theoretical exercise. And of course, shared data, right? And this is becoming more and more important because we're working on things called multi-domain solutions, right? I mentioned earlier about this challenge in the smartphone, for example, where you have a mechanical challenge. And then you have the electrical challenge of trying to put it in there. And then you have the thermal challenge of trying to keep the thing cool. So now all of a sudden, in the context of simulation and design, right, you're dealing with all these various different domains, mechanical, electrical, thermal, and all the data that goes along with that, right? And then that leads us to the third piece, which is, what do you do with that data, the improved intelligence? And I was having this discussion with Bill as he was, running out, because he was talking about data, and people called data currency, right? And I challenged him a little bit, because I said, we actually do think of it as currency, because, all of us with currency, there's a big difference between a penny and a $100 bill. And that, to me, is one of the key things with data, is trying to look at it and determine where the pennies and where are the $100 bills. And, in my case, the pennies are in my pocket and the $100 bills are with my wife. So I'm going to wrap up here with a short video I would like to show you that kind of gives you a good example of this digital thread and digital twin.
Intermechanica was started by my father and my mother in Turin, Italy in 1959. I've been running Intermechanica by myself since my father's passing for about 15 years. I met Jerry on an off chance as a walk-in to my business. Very adamant environmentalist, convinced that electrification of vehicles 15 years ago was the future. I did not share that vision, and on several occasions, ushered Jerry out of my shop so that I could get some work done. He kept coming back, and actually we became friends.
I go by and I drop in and visit with Henry and see what he was doing. And beautiful cars. I mean, they've been beautiful forever, since 1959. Being an advocate for the environment and for technology and using technology to heal the planet, I said to him, Henry, we're going to do something here.
When he brought the concept of a single-passenger, three-wheeled commuter electric vehicle to me as something that he was interested in pursuing and asked me what I thought it was brilliant.
If you look at the numbers, there's not a lot of competition in electric cars. There's still a bajillion gas cars being built. The electric car is like the internet, and a gas car is like a fax machine. Once you drive it, you get the difference.
We knew right away that if we were going to try to meet any kind of timeline, there was never a chance that we were going to be doing this on paper. This had to go from stylus sketch into a digital design immediately.
We weren't told that automotive firms have 200 engineers in a room and it takes them, a year and a half to design a taillight. We just designed the whole car. This car had to hit the ground and actually function. It had to perform like we expected it to. Suspension had to perform. The drivetrain had to perform.
Rich was brought on a little bit later in the process to do finite element analysis, chassis design and development.
What we're looking at is a totally different way of thinking with these smaller companies and the way that they're approaching problems. And they have smaller budgets, but they have more nimble teams. And what they're looking at doing is getting tools which enable them to achieve engineering excellence on small budgets with small teams. And tools like NX, SimCenter allow them to do that.
So we have 75,000 of those cars coming out in the next 3 years, and more manufacturing people that we're reaching out to, top-level manufacturers. When I speak to a top-level manufacturer and I tell them what software we have our car fully designed and engineered on, it makes my life and their life a lot easier to deliver those cars to consumers.
So that manufacturing provider in China, Zhongshen, is also using NX as the primary tool for the design. So they will, take our design, evolve it slightly for high-volume production, and look at all the different moldability, formability requirements that they have for their mass volume production.
We're actually able to talk to our vendors. We're able to talk to our engineer in Michigan, and he's able to talk to Tammy here in our office, and we can talk everything from mechanical bits to electrical components to wiring diagrams and everything else.
With SimCenter, we have a direct parametric link back to the CAD data, all on the one GUI. So that means that we can analyze the design, work out, hey, can we move this? Can we reduce some mass here? Go back into the design, iterate it, 2 clicks, and we have our results updated.
These are things that were new to Intermechanica before we started working with Maya and Siemens and pulling this in. But we brought in some fresh scrubbed young engineers in mechatronics, mechanical engineering, electric engineering. Tammy and the team have done a fantastic job of pulling in what they know, what Henry and I didn't know, what they said, oh, if we can get this software, this is going to be awesome. Faster to market, less chance of error, better value for the end buyer of the car. Maya and Siemens can provide us the tools to make your company great.
SimCenter helps a lot with certification, predicting what might go wrong, help us accelerate the process. If we have all the assemblies sent it out for testing and then come back with feedbacks that it failed, then that would be about like 2-3 months if I do analysis on it. It took me about like a week or 2 weeks of setting it up, and that's way quicker, way faster, and save a lot of time and money. With Siemens and the 3D printer, we can design it, print it out right now. We can get it the next day, maybe 2 or 3 hours later, and then put it in the car, try out if it fits.
So we'll generate our parametric toolpaths here, which is another benefit to keeping everything inside of the one system, have it fully parametrically linked into our CAM software, which is inside of NX as well, and then straight to our CNC machining center.
The engineers that we're using at Electromechanica are so inspired that we can sit around, come up with an idea, or even they're coming up with an idea, or Henry's come up with an idea, boom, it's ready to go. That's awesome. You're literally unleashing the potential of the human being to not just think of a solution that will work, but create it. And there's magic in there.
Great. Thank you very much.
Thank you, Fram. Okay, get on your Twitter account or raise your hand. Who's got a question for Fram? One of the takeaways, I think, of that video is that those young engineers that they featured are about 3 years younger than my shoes that I'm still wearing.
You know, before I get to this question, I want to follow up on that because I mentioned earlier the education piece and kind of the transitions that have been occurring. And they talked in the video about this mechatronics, the combination of mechanical engineering and electrical engineering. And this is also something that you're seeing within industry, which is, it started out the mechanical engineers were in one room and the electrical engineers were in another room, and they never talked to each other. And then, there was a natural progression where they would start to be on the same teams together. Well, now you're starting to see this kind of multidisciplinary type engineering education develop. We had our analyst meeting in Boston last week. We actually had someone, I want to say from the University of Cincinnati, come in and talk about the program that they're doing specifically around that. So it is quite a transition.
Okay, can you further explain the correlation between digital thread and digital twin?
Sure. And of course, everyone will probably have a different definition of this. But for me, I think of the digital twin as sort of being, on one of those charts that I showed, if you pick a specific area, let's take IC, for example. There's a digital twin that you can develop within the IC space that allows you to sort of model between design, manufacturing, and utilization, right? The ideation, realization, utilization. That to me is sort of the digital twin piece. And then to me, the digital thread is tying together all the various digital twins that have been developed throughout the supply chain. So the digital twin for IC, the digital twin for electronics, et cetera. So that's kind of how I explain it.
Okay, any other questions? Over here, please.
So, how How do you, from a cybersecurity standpoint, secure the supply chain, handle the supply chain risk management? Are you using technology? Are you using any sort of digital twins? Are you using any data analytics to guarantee that the components, the raw materials that you get are actually legitimate, they're from the right country of origin, they haven't been tampered with?
Mm-hmm. Yeah, that's a great question, and it's a topic, by the way, that's being discussed sort of on an ongoing basis. In fact, I was discussing it with someone over breakfast this morning. And, you know, I think there's I will say it's an evolving sort of area. There's a lot of discussion about using crypto technologies and things of that nature to address, you know, this idea of counterfeit, particularly on the component front. I know on the Qualcomm side, we were actually, between Qualcomm and people like ARM, who develop microprocessor technology, there's this idea of trust zone and the capability of being able to not only from the outside determine, you know, this component is legit or whatnot, but even being able to kind of go inside the black box of the IC to determine if there's been any sort of corruption happening either from a hardware, firmware, or software component. So it is an area that we're sort of actively involved in. And, you know, with security, it never ends. As you know, you develop techniques, you get to some level of robustness, and then, of course, someone figures out how to break that, and then you have to go on top of that. So it's going to be an ongoing sort of thing, but it's definitely top of mind within Siemens and our customer base.
Okay, additional question? As a student at UCF, we have a number of degree options within engineering and technology. What type of degrees are your companies hiring to engage in the Internet of Things ecosystem?
Well, certainly all types of engineering disciplines, particularly electrical and computer engineering, computer science piece. The other area that I talked about here that's kind of an emerging area is this idea of kind of multidisciplinary engineering, right? Mechanical, electrical, sort of combined together. The other aspect that I think is important, just as important, by the way, again, I talk at a lot of universities, and it's not just about the degree, but, you know, increasingly important are internships and getting experience sort of along the way. The other piece that is also very important is ability to communicate. Communication skills, teamwork skills, etc., also very important. Because at the end of the day, I know myself when I'm going to hire engineers, I'm kind of looking for three things, right? I'm looking for what I call the competency element of the engineering discipline. I'm looking for any pertinent and relevant experience. And then the third thing I'm looking for is this person able to communicate verbally, written, and work within teams? Those are three important words of advice I would give.
Okay, and following up on that, from our universities, are we training the future data analyst? Are we training those people that can mine that data and meet the requirements that Siemens needs in order to proceed ahead with what you talked about?
You know, it's kind of a yes and no answer, because I think, you know, we have a lot of people here from universities and industries, and they'll tell you there's always this chicken and egg between industry and university. And the thing that, the point that I really liked, right, I think Bill made it this morning, was it's important that we train folks to kind of be able to think critically, right, and adapt. Because any one of us who have been in the industry for a while, you know, if I think back of the coursework and the things that I did as an undergraduate and even in graduate school, and what I'm doing today, you know, the direct applicability, not really there, but the ability to sort of think critically, adapt, to change. There's a great, actually, little sign that I have in my office. And it says something to the effect of it's not the strongest or the smartest, but the people that are best able to adapt to change, right, that survive. And so that's something that I think is kind of very important. And that's why I mentioned those three things, right? Because I think the adaptability is directly related to, the competency, the experience, and the ability to communicate.
Questions from the audience? Anybody with their hand up? Okay, so we gave you a 30-minute time limit for your presentation.
Yep.
We then said we'd have 15 minutes worth of Q&A. Mm-hmm. I suspect you probably had to take the material and whack at it a little bit, take some stuff out. So we just gave you another 5 minutes. What is it that you didn't talk about that you would have liked to?
Well, I could go through a lot more jokes, but I won't do that. Couple other points I'll make just on the education piece, because again, I think that's something that's passionate for me, and reiterate a couple points or reinforce some points that were made earlier, because both myself and my wife are both engineers, and we actually spend a lot of time giving back into universities and whatnot, including things around STEM and STEAM, depending on what term you use. And there was a point made this morning I'd like to emphasize on how important it is to start young, particularly with women and other underrepresented groups within the engineering community. 5th grade, 6th grade, et cetera, kind of exposing them in a cool way to what engineers do and can do. I think that's a really sort of important point that I think I wanted to emphasize. The other thing that I would emphasize is, again, kind of a point I've already made, which is this multidisciplinary aspect around engineering. So for the folks that are here from university, I would strongly encourage you to, kind of continue to look at that. Universities, like industries, right, can have silos as well. Particularly I've seen between various disciplines, electrical engineering, mechanical engineering, et cetera. And so I would also strongly encourage kind of break down those silos and look for ways to ensure that the engineers coming out have the ability to have these kind of multi-domain, multidisciplinary skills.
Anybody come up with a question? It appears not to be the case. Well, Fram, I know you've got to catch an airplane here pretty quick.
Yes.
We thank you very much for carving out some time, coming and joining us.
It was my pleasure, Tom, and pleasure for the group as well.
Thank you.
Thank you, Tom.